My name is Ridanshi Shotia and I am going to start information theory. What is basically information? Information is something that holds a message that we need to transmit from one position to another position. In information theory, we have communication system. With the help of this communication system, we transmit information from one destination to another destination called transmitter and receiver. It's a one-way transmission of information. Now, what is information? Information holds some message. If an observer receives a surprise in an information, we can say that it's a information. So I'm making it more clear. What we can say about information: an event that causes surprise to an observer is called an information. In later stages, we will come to know about its mathematical modeling. But in literal meaning, we can say that it's a message that an observer who is going to receive. So, continuing this part, I am also going to add here. Shannon work also focused on transferring message over noisy channels. So, what he has done, at the receiving end, the message can be recovered with low probability of error. So what Shannon focused, that having a noisy channel also, we can recover the message what we have transmitted at the transmitter end. So our main focus must be low probability of error. The content I explained is about the definition of information. Now we will move towards the mathematical modeling. So I will again start with my next section, which is, if I am going to say what is information source. What happens if there is an object, then it is going to produce some event. Here it will be outcome, okay, selected at some random probability distribution. So this is called the information source, and with the help of these steps, I am making it more clear, the information source theory. Now we can move towards its classification. What does its classification say? That it can be of two types: information, okay, with memory and without memory. What happens in with memory type of information sources? They will hold the previous content also. Their output will depend on the previous content also and present content also. So we will get the final output depending on the past outcomes also. But what happens in without memory, that is memoryless information sources? Here It will not depend on the previous one, and the current outcome of probability distribution, which is also called as DMS, that is discrete memoryless source. I'm making it more jumbled. Now I can rewrite as discrete memoryless sources. Now the next section is message containing knowledge of high probability of occurrence convey little information. So what I am going to say is, if event is certain, then there will be zero information. We are moving ahead towards the information content of symbol. So before going to this section, some properties are there. We need to focus on them. So to make it more elaborate, I am giving an example. If sun rises in east, it's a truth. It has no information content because its probability will be 1. Sun rises in east, so there is a zero information. So something about information content of symbol. It can also be written as logarithmic measure of information. Logarithmic measure of information. Now DMS denoted by X.
जरूरी नहीं है तुम्हें.
Denoted by X. Having alphabet. Alphabet X1, X2, Xn. So what happens if PXI is probability distribution? Then IXI, the information content, will be log of 1 upon PXI minus of log B PXI. This is the important expression we are going to use again and again throughout the information theory chapter. Here we get an expression in terms of logarithmic factor, that is log B, log to the base B, 1 upon PXI. Now it is important to note about the properties of information. I can write it as properties of IXI. Here IXI equal to 0 for PXI equal to 1. If information content is 1, means information content is 0, then probability will be 1, which I have already explained in the example, that if sun rises in east, then its probability will be 1. So information content will be there 0, and this is the worst case. It should be a positive quantity or it should be non-negative. IXI must be greater than equal to 0. This is property 1, property 2. Property 3 will be IXI greater than equal to I of xj. If P of xi is less than equal to P of xj. Now the last property, the information content should add. So I can rewrite it as IXI XJ IXI plus of IXJ. If XI and XJ are independent events only, the point should be here more clear. We can apply this function only if Xi and Xj are independent events. Otherwise, this will not be applicable. So these are the main four properties of information, of any information content, which is required to be followed to get the proper information. Now we are moving towards its unit. What is its unit? I have already shown that in its expression there is log to the base b pxi. So unit for b, if b equal to 2, then it's can be written as bit binary unit binit. If b equal to 10, then it can be Hartley or Disitt. If b equal to e, then log 2a equals to ln a over ln 2 equal to log a over log 2. This is the expression for calculating logarithmic of a with the base 2. We can calculate with natural log ln over ln a over ln 2 log a over log 2. So important points to ponder here. What we have concluded with these expressions is, if IXI approaches to 0, then PXI approaches to infinity. Example I have already given. Now this is once again the important point. IXI must be greater than 0. It should be a non-negative quantity. Each message contains some information. This means that each message must contain some information. So up to now, I think this will be more clear. Now we can have some examples to make it more clear how we can calculate the information content if some probability distribution given. Px, let us suppose Px1 is given as half, Px2 is given as 1/4, Px3 equal to Px4 equal to 1/8, and we have to calculate the information content. So how I am going to calculate? Ix1 log 2 1 upon Px1. So I am just writing the Px1 value. From here I get log 2 to power 1, that is 1. Here the information content value is 1 bit. I must write its unit. Ix2 log 2 1 upon Px2 given as log 2 1 upon 1/4 log 2 to the power 2, there is 2 bits. Again for Ix3 equal to Ix4, because probability distributions are equal, so I can write it as log 2 1 over Px3 log 2 1 over 1 by 8 log 2 to the power 3 3 bits. So this is the general expression for calculating the information content if particular probability distribution values are given. Now I am moving towards the next example, which is if I have given as calculate the amount of information if bits occur with equal likelihood in a binary PCM system. So अगर bits are equally likelihood, then it can be 0, it can be 1. So their probability of occurrence is half. If events are 0 and 1 only, then its probability it's half. Its probability is also half. Then information content again, IEXI log 2 1 over PXI, that is log 2 1 over 1 by 2, then log 2 to raised to power 1 bit. So for the events which are likelihood in a binary PCM system, we get the information content that is 1 bit. Now moving towards the next question, I am taking questions from very base level so that we can clear all the points in this chapter. If in a binary PCM system 0 occurs at a probability of 1 by 4 and 1 occurs with a probability of 3 by 4, then calculate the amount of information carried by each binary. This is occurring with a probability of 1 by 4. 1 is occurring with a probability of 3 by 4. So I am going to calculate for IEX1, that is for 0. So what happens here? Log B 1 over PX1. This will be 2. For calculating IX2, here log B 1 over 3 by 4, and this can be log B 4 by 3. And for resolving this expression, I can rewrite it as log to the base 10 4 by 3 log to the base 10 2, and after solving this I will get the desired result 0.4415 bits. So here I have solved the questions as much as possible related to information in a simple manner. And I will continue this again to next level with some more example, and the next topic will be entropy that we are going to focus.